There's a gold rush happening right now, and it is not taking place in California or in the deep jungles of Africa or at the bottom of the ocean. It is happening 250,000 miles above your head, on the surface of the moon. Private companies are pouring hundreds of millions of dollars into technology, missions, and infrastructure with one singular goal: to go up there, dig into the lunar surface, and bring back resources that could be worth more than anything ever pulled out of the ground on Earth. This is not a distant dream being discussed in university labs. This is happening right now, in 2026, with rockets being built, rovers being tested, and serious money changing hands for resources that have not even been extracted yet. The Moon Gold Rush is real, and the companies leading it are about to change the entire foundation of the global economy. To understand why the moon has suddenly become the hottest piece of real estate in the solar system, you have to understand what is actually up there. Most people think of the moon as a dead, barren rock, and compared to Earth, sure, it looks that way from the outside. But beneath that gray, dusty surface is a treasure chest that makes every gold mine in human history look like a backyard sandbox. The lunar surface is loaded with titanium, aluminum, iron, and silicon. There are deposits of rare earth elements that the entire global technology industry is desperately hungry for, given that the world's supply of these elements on Earth is concentrated in just a few countries and is being consumed at a pace that cannot be sustained for much longer. There is water ice locked in the permanently shadowed craters near the lunar South Pole, and water in space is not just for drinking. Water can be split into hydrogen and oxygen, which are rocket propellant. That means whoever controls the water on the moon controls the refueling stations for every mission heading deeper into the solar system. But the resource that has sent investors into an absolute frenzy, the one that is drawing comparisons to oil, to gold, to uranium, is something called Helium-3. On Earth, Helium-3 is almost impossibly rare. The total amount stored in research facilities around the entire world is measured in kilograms. But the moon has been bombarded by the solar wind for billions of years. And that solar wind is rich in helium-3 particles that have accumulated in the lunar soil over geological timescales. Scientists and energy researchers believe that helium-3 could be used to power nuclear fusion reactors, a technology that, if it reaches maturity, could provide virtually unlimited clean energy without the dangerous radioactive waste that current nuclear power produces. The price of helium-3 on the current market sits around $20 million per kilogram. Even conservative estimates of helium-3 deposits on the moon put the total value at figures so large they are genuinely difficult to comprehend. Now, you understand why companies are sprinting to get there first. The first company you need to know is Interloon, and if you have not heard of them yet, remember the name because they are about to be very famous. Interloon is a Seattle-based startup founded by former executives from Blue Origin, including Rob Meyerson, who spent years helping Jeff Bezos build out Blue Origin's rocket program before leaving to pursue what he describes as the single biggest economic opportunity in human history. Interloon's entire focus is on one thing: helium-3. The company has raised over $18 million in early funding and has been developing what it calls a breakthrough extraction method for pulling helium-3 out of lunar regolith. Their technology involves an electric lunar excavator that can process enormous quantities of lunar soil, reportedly up to 100 metric tons per hour, heating the regolith to release the helium-3 trapped inside. The company plans to send a multispectral camera to the moon's south pole to map exactly where the richest helium-3 deposits are located, followed by sample gathering missions in 2027 and a pilot extraction plant by 2029. Interloon has told its investors it could realistically be generating $500 million in annual revenue from helium-3 sales within a decade. The Washington Post reported that Interloon has already signed the biggest purchase agreement for natural resources from space in history, before a single gram has even been brought back. That is how seriously the market is treating this opportunity. The second company leading this race is ispace, a Japanese firm that has been building toward lunar resource extraction longer than almost anyone else in the private sector. ispace was founded with one explicit mission: to expand human presence on the moon and turn lunar resources into the foundation of a space-based economy. The company has over $174 million in funding, making it one of the best capitalized pure lunar companies in the world. ispace's approach is different from Interloon's in that they are building the entire infrastructure stack, landers, rovers, and surface operation systems, rather than focusing on a single resource. They believe the key value of the moon is its water ice, specifically the ability to process that water into rocket propellant that can be sold to spacecraft operators in lunar orbit or on their way to Mars and beyond. Think of it as a gas station in space, positioned at the most strategically important location between Earth and the rest of the solar system. ispace has already flown 2 lunar missions, Both ended in crash landings on the surface, but the company gathered enormous amounts of data from each attempt and continues to push forward. In January 2026, was selected for a major Japanese government contract to develop high-precision landing technology for the lunar polar regions, the exact areas where water ice and helium-3 deposits are most concentrated. They are learning from every mission, building capability, and they are not going anywhere. The third company on this list is Astrobotic Technology, a Pittsburgh-based company that has positioned itself as the logistics backbone of the entire lunar economy. Astrobotic does not just want to mine the moon, they want to be the company that gets everyone else's hardware to the moon cheaply, reliably, and repeatedly. Their Peregrine Lander and Griffin Lander programs are designed to carry payloads for NASA, commercial customers, and international space agencies to the lunar surface. What makes Astrobotic critical to the Moon Gold Rush is simple. You cannot mine something you cannot reach. Every mining company needs a reliable way to land heavy equipment on the lunar surface, and Astrobotic is building the transportation network that makes that possible. The company has contracts with NASA under the Commercial Lunar Payload Services program and is developing the Griffin lander specifically to carry the large, heavy surface systems that serious mining operations will require. Astrobotic is the railroad company of the Moon Rush. They may not be the ones holding the pickaxes, but without the railroad, nobody gets to the gold. The fourth company is Intuitive Machines, and their story is one of the most dramatic in the entire new space economy. Intuitive Machines became the first private American company to successfully soft land a spacecraft on the moon in 2024 when their Nova-C lander touched down near the lunar South Pole, the first American lunar landing since the Apollo era over 50 years ago. The landing was not perfect. The lander tipped onto its side, but it worked, and the achievement was enormous. Intuitive Machines is now building on that milestone aggressively. Their Nova-C landers are designed to deliver scientific instruments and resource prospecting equipment directly to the lunar South Pole region, the exact area that every mining company on this list is targeting. They are developing systems for soil analysis, subsurface imaging, and resource mapping that will give future mining operations the detailed geological data they need before committing to full-scale extraction. Intuitive Machines has NASA funding, commercial contracts, and a track record of actually landing hardware on another world. In an industry full of companies that are still years away from their first mission, that matters enormously. The fifth company is one of the most interesting and least talked about players in the moon economy, Lunar Outpost. This Colorado-based company made history in 2021 when NASA actually paid them to mine the moon. 10 cents, the first ever commercial lunar mining payment in history. Symbolic, but real. Since then, Lunar Outpost has been developing rovers and surface mobility systems specifically designed to support resource extraction operations. Their MAP rover was delivered to the lunar surface and is designed to traverse the challenging terrain of the lunar South Pole, mapping resource deposits and supporting larger mining infrastructure. What makes Lunar Outpost particularly important is their focus on the practical, ground-level operations that actual mining requires: mobility across rocky and cratered terrain, dust management, systems that keep equipment functioning in the abrasive lunar environment, and autonomous operation software that allows rovers to work continuously without waiting for commands from Earth. The communication delay between Earth and Moon is not massive, but in a fast-moving mining operation, the ability to make decisions autonomously on the surface is worth an enormous amount. Now step back and look at all 5 of these companies together, and a picture emerges that is bigger than any single organization. What is being built right now, piece by piece, is an entire industrial economy operating on another world. Interloon provides the extraction technology. ISPACE provides the landers and surface infrastructure. Astrobotic provides the transportation network. Intuitive Machines provides the precision landing and site survey capability. Lunar Outpost provides the surface mobility and operation systems. These companies are not just competing. They are also, in many ways, building the different layers of the same overall system. A lunar economy needs all of these functions working together, and the fact that multiple serious, well-funded companies are developing each function simultaneously is a sign of just how real this is becoming. The legal framework around all of this is still evolving, and that creates both risk and opportunity. The Outer Space Treaty of 1967, which governs international space law, prohibits any nation from claiming sovereignty over the moon. But it says nothing definitive about whether a private company can extract and sell resources from the lunar surface. The Artemis Accords, a US-led framework that now has over 60 signatory nations, including Japan, Australia, Canada, and most of Europe, take the position that resource extraction is permissible as long as it is conducted transparently and sustainably. China and Russia have not signed the accords and are pursuing their own lunar program with plans for a joint international lunar research station by 2035. The moon is becoming a geopolitical arena as much as a commercial one, And the companies moving fastest are the ones that will have the most leverage when the legal framework finally solidifies. The space mining market is currently valued at over $3 billion in 2026 and is projected to reach nearly $7.5 billion by 2031. Those numbers sound large until you remember that even a modest helium-3 extraction operation on the moon could generate revenues that dwarf the entire current market in a matter of years. The economics are almost incomprehensible when you run the numbers fully. But what makes this moment in history genuinely important is not just the money, it is what the resources enable. Water ice converted into rocket propellant means that the cost of deep space exploration drops dramatically. Missions to Mars, to the asteroid belt, to the outer planets, all become more accessible when you do not have to carry every drop of fuel from Earth. Rare Earth elements mined on the moon reduce pressure on Earth's dwindling deposits and could accelerate the clean energy transition. Helium-3, if fusion power reaches maturity, could end the world's energy crisis in a way that nothing on Earth currently can. The Moon Gold Rush is not a metaphor. It is not a sci-fi scenario. It is a commercial and industrial race that is happening right now, with real companies, real hardware, real funding, and real missions, either already flown or launching within the next few years. The 5 companies leading it, Interloon, ISpace, Astrobotic, Intuitive Machines, and Lunar Outpost, are writing the first chapter of what will eventually be recognized as the most transformative economic expansion in human history. And unlike the original gold rush of 1849, this one does not just change a single country or a single economy. This one changes everything. Word count. Tau 490. The cost of access to the moon has changed in a very short period of time. 10 years ago, getting even a small spacecraft to the lunar surface cost hundreds of millions of dollars and required a partnership with a national space agency. Today, commercial landers are making the trip for a fraction of that cost, and the price is continuing to fall as the technology matures and competition drives efficiency. That declining cost curve is what has unlocked the economics of lunar mining in a way that was simply not possible before. When the price of getting 1 kilogram of hardware to the moon falls below a certain threshold, the math on extracting and returning resources starts to make commercial sense. We are approaching that threshold faster than almost anyone predicted even 5 years ago. The countries and companies that move aggressively right now, that land hardware, prove technology, establish operational presence, and build relationships with governments and customers on Earth, are the ones that will define the rules of the lunar economy for the next century. First mover advantage in space is not just a business school concept. It is a physical reality. The best landing sites near the lunar South Pole, where sunlight is nearly constant for solar power and water ice is within reach, are limited in number. The best helium-3 deposits are in specific locations. Whoever plants equipment on those sites first, whoever builds the infrastructure that future operations will depend on, holds an advantage that late arrivals will struggle to overcome regardless of how much money they eventually throw at the problem. This is the Moon Gold Rush. The starting gun has already fired. The companies that recognize the opportunity early are already in motion, already learning, already building the capabilities that will matter most when full-scale operations begin. The rest of the world is just starting to pay attention. And if history tells us anything about what happens when a new frontier opens up and serious money starts flowing toward it, the pace of development over the next decade is going to be breathtaking.